Welcome back, class. In the last lecture video, we discussed how negative numbers can be thought of as special types of numbers that allow one to express the quality of an object. We said that this is especially evident when you're talking about an object that's in motion, such as moving in an upward direction, where we would say that if an object moves in an upward direction, that is a positive direction. But if an object is moving in a downward direction, we would say that's a negative direction. And so if an object is moving in a, say it's moving 10 feet in an upward direction, we would say that's positive 10 feet. But if an object is moving in a downward direction 10 feet, we would say it's a negative 10 feet. Okay. And of course, we can also use a positive and negative to represent moving eastward or westward, where we say that if an object is moving in a eastward direction, that is a positive direction. And if an object is moving in a westward direction, that distance or that direction is a negative direction. There are a couple of problems, however, with the idea of negative numbers. And the main problem that arises is simply that in a lot of different scenarios, in particular in accounting and management, in business, we often actually don't care about describing, say, the direction of something. We just care about the total amount of that something. Okay. An accountant's job is to figure out how much money exists in the bank accounts of a business or someone's personal bank account in order to determine how much taxes are to be paid to the government. In short, that's what an accountant does. Now, the amount of money that's in someone's account or that's moving out of an account can be represented as, say, positive and negative numbers. But from the accountant's perspective, it really doesn't matter whether the money's in an account or whether it's moving from one account to another account. They want to account for the total amount of assets on the books. And often the case is true in business and management contexts as well, where you're doing very similar things. So this is the issue at hand, is we often actually don't care about the quality of that something. And because of this is what makes negative numbers confusing to children. Because if a child thinks about moving up a mountain and they have to travel 1,000 feet from the base to the summit, well, the child says that's the same thing as if I move from the summit down 1,000 feet. 1,000 feet is effectively the same thing as 1,000 feet, whether you're moving from the bottom to the top of the mountain or the top of the mountain to the bottom of the mountain. It really makes no difference. And so for a child, when you start to introduce the concept of negative numbers, because they don't have the amount of experience that's necessary to understand the utility of a negative number, they might discard the idea altogether and just say that we're making the math more complicated than necessary by essentially attaching a quality to the numbers when the numbers are just the numbers in the child's mind. Okay, so that's the challenge of negative numbers. And this brings us to the idea of absolute value. So the absolute value is denoted or has a specific notation, which is as follows. The absolute value will be denoted using two parallel bars that are going up into the sky, that are going vertically. And this is shorthand for find the absolute value of that something. So an example of this looks like if I have two vertical bars and a -5 in the middle of these vertical bars, we're supposed to interpret this as the following. We're going to interpret this as find the absolute value of -5. The absolute value symbols don't really do anything apart from act as a shorthand way of asking a question. So this is the notation of absolute value, but what does it actually mean? Well, it means that, going back to this example, if instead of moving up into the sky 10 feet or down 10 feet, you had moved up 5 feet and or down 5 feet, naturally you could represent that downwards motion as a -5 feet. However, if you were to actually take a ruler or a yardstick and measure out 5 feet, you'll note that it doesn't matter what direction I place that yardstick. 5 feet is just effectively 5 feet, regardless of the orientation of the yardstick, right? And so that's essentially what is meant by these absolute value symbols. If you were to imagine taking out a yardstick and measuring some distance or some amount of something, it really doesn't matter if it's a negative value or if there's, or rather, said another way, if there's a negative symbol attached to that value, the total amount of that something is just the quantity without regard to the negative symbol. So now a lot of students are going to, at some point in time, try to Google the absolute value uh, formula in order to try to maybe find a walkthrough online, maybe through YouTube and whatnot. And if you do Google absolute value and you look on the Wikipedia page, you're going to be confronted with a rather nasty looking formula. The formula has the following notation. Usually there will be an absolute value bar that surrounds, say, a letter such as A. And then there will be this nasty looking brace, which is pointing to the right. And it says something like, if A is less than 0, then you take a negative and multiply with A. And then if A is strictly greater than or equal to 0, then you just get A. And the question is, how are we supposed to interpret this nasty looking formula? Well, the first thing that I would tell students, and I would tell my master's students or even PhD students the same thing, is that anytime you've got a nasty looking formula, try to describe to yourself what this formula is referring to using words. So this symbol right here is just saying find the absolute value of a number. That's all it's saying. The letter A is not literally the letter A. It represents a variable, which we talked about in earlier classes. And we said a variable can represent any number, any value. This variable could be -1. This value could be -10 million. It could be 10 billion. Uh, I don't know what A is. You don't know what A is. A can be whatever we want it to be. But whenever you see these absolute value bars surrounding A, it just means find the absolute value of a number. Now, to do this, you need to check. You're going to check two conditions. If A happens to be less than 0, you're going to slap a -1 and multiply with that value. What this does, or what this means to you, is it actually means just remove the negative sign. Okay? And on the other hand, if the value that's between the absolute value bars happens to be greater than or equal to 0, then you're just going to leave it alone. So there's two options. Either the value of A is less than 0, or it's greater than or equal to 0. It can't be anything else. So let's take a look at what that looks like. So here are some examples. So suppose we took the absolute value of -15. What this formula above is telling you to do is it's literally telling you to, first of all, remove the absolute value symbol, because on this right-hand side here where you see the -1 times A, you don't see any absolute value symbol at all. And really all it's saying is that you're going to write a -1 and multiply with whatever number happens to be inside of the absolute value. So in this case, inside of our absolute value, we have -15. Right? So I'm just going to rewrite -15 and I'll multiply by -1. According to our rules of negatives, a negative and negative is going to be a positive, and then you will just take 1 and 15, multiply those together, and you should get 15. That's essentially how you're going to work through these absolute value problems. Now, at some point, you're going to get so good that you'll remember that whenever you're taking the absolute value, it just means to clear the negative symbol. And in fact, many of you who don't have any problems at all with this content can just do just that. But it's important to know exactly how the absolute value works. Now, if I took the absolute value of 15, what would happen is taking the the absolute value of 15 is essentially just spitting out the number we were given. So 15 is already a positive number to begin with. If I measured 15 feet with a yardstick, I could do that in any direction. It doesn't matter. 15 feet is 15 feet. So I'm just going to write 15 feet. Second example, if you had, say, the absolute value of -8, because this value is less than 0, i.e. -8 is less than 0, you're going to take -8, and all you have to do is multiply it by a -1. Negative negative becomes positive. You will have 1 times 8, which gives you 8. Now, I don't know if you will see variable style questions in MyLab Math homework, but if you do, here's how to work through it. You might have an absolute value bar that surrounds some variable like -x. And of course, students are like, well, I don't know if -x is a positive number or a negative number. I don't know what to do with it. And of course, they're right. I don't know what x is. You don't know what x is. So if you took the absolute value symbol, wrapped it around -x, it's not asking you to perform a calculation. That's not what's being asked. It's asking you for you to determine the absolute value. Now, what you're going to learn in an algebra class and what's a little bit more abstract than perhaps the way you were taught to think about math when you were in your lower level math courses is that um, because we don't know what x is and we're taking the absolute value, we literally just have to follow these definitions. Well, the definition of absolute value says that if my number that's in between the symbols is less than 0, just slap a -1 in front of it. So that's what we're going to do here. We're going to take a -1 and we'll slap it in front of the -x. Negative negative becomes positive, and you will have 1 times x, which just gives you x. And that's our answer.